Yeah, those I'm going to be talking in English because we have a lot of people that are enrolled for this summit. So welcome to the NICR 43 Freeway Incident Detection and Management using Unmanned Aircraft Systems Virtual Summit. My name is Yvette Cruzado. I'm a professor in the Civil Engineering and Survey Department at the University of Puerto Rico in Mayagüez. And it's my pleasure to be here with you and welcome you to this experience and this opportunity. This is a summit. It's sponsored by the National Institute for Congestion Reduction. We call it NICR. And we have our partners from the University of South Florida here that are going to be saying hi to you later. And I want to show you the agenda for today's summit. We're going to start with the welcome remarks. So I understand that we have the engineer Adrian Gonzalez, the Executive Director for the Puerto Rican Highway Authority online. So we're going to start with him. Go ahead with this slide. And as you can see, he has a lot of experience, but I remember him from the little project that we had with the Public-Private Partnership Authority. And it is my pleasure to welcome Dr. Adrian Gonzalez Montalvo. So please, how you doing? Is everything okay over there?
Yes, I'm here. Good morning. Definitely a pleasure to be introduced by Dr. Yvette Cruzado here. Welcome, everyone. I'll be talking a little bit more later on this morning, but certainly appreciate LTAP's and Dr. Colucci's always best. He always puts his best foot forward, right? And this is an excellent example of how we are in PRHTA and Puerto Rico innovating and using different new technology to better our road system and the user's experience. So looking forward to the conversation this morning. Thank you all.
Rico Civil, I have to admit that, you helped me a lot. Maybe I would not be here if it wasn't for Juan Rivera, who is the Federal Highway Administration, is the Puerto Rico and the Virgin Islands divisions. Juan Carlos, will you please come over here to the stand and talk to our audience? So happy to see you.
I am happy to, Ivan. Thank you for those kind words. You were a very great partner for us as part of the university. I have a brief presentation from Federal Highway training. This is a very important summit. Let's say we are going to combine innovation and operation. Those are two very important programs as part of Federal Highway. When we talk about innovation and operation, we want to integrate those two programs because we are looking for a reliable, safe operation and highway system. And as part of this training, we are going to see several topics that we heard about here in Puerto Rico to achieve that goal. Next. Allied. Here we have professors from the University of Mayagüez, professors from the University of South Florida, also the executive director from the PRCA. We have consultants from PRCA that we talk about ITS programs and the different innovations that they are deploying. And we have the federal. We are working together to look for new alternatives that can help us to reduce congestion, especially in the San Juan metropolitan area and also other important areas here in Puerto Rico. Thanks. In Federal Highway, we have the Everyday Count program. This program, we are looking for new innovations every day to implement in the different states to save time, money, and resources. Here in Puerto Rico, as part of Everyday Count 6, Puerto Rico selects two innovations that are in the operation program. Those are Crowdsourcing for operations and next generation team. I'm not going to explain or provide more details about those two innovations because we will have as part of the agenda a very good presentation from the PRCA conference. Also, We will have two other presentations about unmanned aerial systems, another very good tool and device that will help us not only in the traffic incident management, but also as part of the traffic study and the evaluation of traffic in our freeways and interiors. Remember that in Federal Highway, we have two excellent programs to provide funding. The STIC, State Transportation Innovation Council, when we provide 100,000 each year for innovation. Puerto Rico Highway Transportation Authority has several projects to acquire different tools, especially in the ITS program with those funds. The another program is the A-Demo. In that one, we can have up to $1 million every year. So we invite everyone to learn about those two programs and complete different proposals. Finally, I like that poster that was developed by Puerto Rico ERTAS as part of the STIC program. We can see the roadmap of innovation here in Puerto Rico. It's not only in operations, it's in safety, in payment, in bridges, in other important programs from 2010 to the present. We need to continue encourage promoting innovation in our program if we want to have a very good implementation of infrastructure and other congestion programs. Enjoy this summit and thank you for the invitation.
Thank you. Now, don't take it personal, but just in case, it's my first outing. I still love you, okay, good. Okay, good. Alrighty, next, and last welcoming remark is going to be Dr. Ben Ecology, my colleague at the University of Puerto Rico in Mayagüez, and he's going to be in representation where the building where we are, sorry, which is the Civil Engineering and Survey, no, I forget the CAPR, how to translate CAPR.
College of Engineering.
College of Engineering and Surveying, Surveying Board
Of Puerto Rico.
of Puerto Rico. There's no colegio in there.
College.
Okay, college, all right. So he's gonna be the last person for our welcoming remarks.
Thank you very much, Dr. Adrian Gonzalez, and welcome everyone. On behalf of Engineer Juan, the President of the College of Engineers and Surveyors of Puerto Rico, we give you a warm welcome to the facilities, the headquarters here in San Juan, Puerto Rico. The College of Engineers and Surveyors of Puerto Rico was established in 1938. We're celebrating now our 83rd anniversary. The president yesterday was his birthday, and he had other commitments, previous commitment with the mayor of Caguas. But he told me to express our gratitude that you are here and you selected this facility to mention the latest innovations associated with drones, unmanned aircraft systems, and to share this information with our practitioners, the engineers and surveyors of Puerto Rico. Hopefully, this innovation will be of benefit to the practitioners in the different fields of engineering, inspection of bridges, other infrastructure, and in our case, to improve on vehicle, on traffic incident management and freeway operations. I hope you enjoyed the presentation, and we wish you at the College of Engineers and Surveyors Merry Christmas and Happy New Year 2022. Thank you very much.
Okay, thank you, Kalushi. So I hope everybody's doing okay. We're going to start now with a little introduction about what is NICR, the National Institute for Congestion Reduction. It's a project with the collaboration in University of South Florida, and our PI or principal investigator is Dr. Alberto Figueroa.
Thank you, Dr. Cruzado. I'm very happy. Sorry about that. I'm very happy to be here with all of you. I'm in a great presence here with all the speakers from the University of South Florida. I welcome with open arms in our beautiful islands. We have people from Federal Highway, Mitigation Engineering. Also, we have professors from University of Puerto Rico and students. So I'm here to talk a little bit about NICR and what it represents for the nation and also for Puerto Rico in our case. So this presentation is a brief introduction of what NICR is. NICR is the acronym for the National Institute for Congestion Reduction. This is a UTC, University Transportation Center, that was approved in 2019 by U.S. Department of Transportation regarding the topic of congestion. We all know about the issues that congestion brings into our lives, the productivity that is lost, the hours lost, and we have a center that focuses on innovations in different technology advances that we can have multimodal strategies. This is not about just highways. This is not just about building bigger highways. This is about a transportation system that is more efficient and it can help sustain the quality of life for our residents. And this center is composed by 4 universities that lead the way in congestion mitigation research. And those are the University of Florida as the lead university of the consortium. We have the University of California, Berkeley. We have Texas A&M and the Texas Transportation Institute. And also we have the University of Puerto Rico, Mayagüez. So when you think about it, you have California, Texas, Florida, and Puerto Rico, who are some of the states and territories with the largest amount of congestion in the public highways. So this is what NICR does. We are looking for innovations, technological advances, scientific research that can advance the state of congestion mitigation strategies for the nation. I will use Puerto Rico as an example. Obviously, San Juan metropolitan area is one of the top 25 cities in the country in terms of congestion levels. So if we talk about San Juan, in just a matter of years, you know, from 8 hours of delay that we had on highways back in 1982, right now, 2017, is 58 hours. You know, it's an average per person, hours lost in congestion. When you think about it, it's a huge amount of time that you spend just sitting down in your car waiting for traffic to move. So that's a huge, you know, productivity loss that we as a nation have to obviously attend. And it's not a matter of just building more highway lanes. It doesn't work like that. We have 60 years of experience working on this issue. That you build more highways, it doesn't mean that congestion is going away. And in some cases, it is even have worsened in some locations. So for those who are getting credit hours for education, that's the first key word that you have to remember. In Spanish, 58 hours, 58 horas. So remember that for those who are applying for credit hours, that's the first keyword. So what NICR does in terms of research in congestion mitigation? Well, we have a research plan that is based on 4 pillars, and that's working with big data, urban and rural traffic management, incentivizing transit as one of the alternatives to improve congestion in our cities and help ease congestion, and also innovative mobility platforms, and also like this project is focused on pillar number 4, battling congestion on freeway corridors. So we have a huge research plan, and this project that you will see is one of those projects for NICR. In the case of Mayagüez, we have obviously a multidisciplinary team. Here with me, I have 4 professors all together from the transportation area in Mayagüez. But this year and a half, we have been 7 professors from different areas working with 26 students, undergraduate, graduate students from different departments working on this project. So for the students, it's a huge opportunity to learn about how to deal with congestion and how we improve transportation system. So in this case, my presentation is going to focus on Puerto Rico, what we have done with NICR projects in this year and a half. We are actually in the 2nd year of the project. So obviously, 2 of those projects you see on the screen, we have 6 projects altogether. 2 of them are already completed, and we have 4 projects running. So I'm going to talk a little bit about it. I don't have too much time. So I'm going to give you a glimpse of what we have done in Puerto Rico related to NICR. One of the projects was a collaborative project with the Texas A&M University dealing with managed lanes. We have in Puerto Rico actually right now 2 facilities with managed lanes. So we had the opportunity in Puerto Rico to analyze data from the PR22. That's one of the highways with more traffic in the island. And we were able to analyze data, all transaction data, to calculate performance measures so we can analyze and compare with other facilities in the states from Texas, Minnesota, California, with Dr. Burris from Texas A&M. We analyze those systems and we try to compare different pricing mechanisms and see what's the benefit of those mechanisms in terms of traffic congestions. One of the benefits locally for Puerto Rico, with that data, with those performance measures, we develop a prototype that we think that the highway authority or the operator of the freeway can use to analyze the data. We analyze travel time index, travel time savings, reliability with the planning time index, and we calculated other performance metrics. I don't know if you can help me, Irmali. There is a clip here in the video. That's a video that shows a prototype. It's just a short video. Can you put it on? So this is one of the technological, advances that you can promote with the users or use it as an analysis tool. So you can see how the traffic is performing on the highway, on the freeway, and try to detect, identify trends that can help you identify decisions on how to improve the system. So this is just a demonstration of how the tool that we develop with students using the traffic data from the freeway, they can see the trends of traffic speed, number of vehicles, performance measure in terms of speeds and counts. So this is a new way that this can be uploaded online, and people on the web can check, okay, at that time, this is how the freeway is performing, and can take better decisions in terms of travel. It's like having, it's like a mapping application, but this time with data in terms of okay, I want to plan my trip, and what's the best time, what's the worst time, and so on. So this is one of the products we developed in that project. We also talk about equity. Obviously, equity is a huge issue right now for our transportation system. So we had a project related to the e-scooter system in the city of Mayagüez, and we had access to data, trip data from the system, and we analyzed it to find what are the main users of the system, what type of trips they are doing. And very important in that project, we figured out, based on the information, that the e-scooters replace some of the trips that people do while searching for parking in a university campus. We didn't get to quantify how much reduction was in reality, but we found a trend that people that used to go in their cars to search for parking in the city were using instead e-scooters to make those short trips around the city. So that's a huge improvement for congestion in the city. Another project related to technology is this one that's very interesting and very important for transit users, is the One Bus Away implementation in Mayagüez. This is an open source application that the University of South Florida developed and is implemented in various cities across the world. And now we are working with our researchers from University of Puerto Rico, Mayagüez, and University of South Florida, implementing this as a obviously user tool and also for us research tool, because this will help us obtain data from the system, how it's being used, ridership data, ridership trends, so we can obviously help the system improve their service to the users. So it's a very useful application. You see screenshots of the actual smartphone application for Android and iPhone. Imari, can you click on the right side? So this is very close to being implemented. We are working with the municipality of Mayagüez, working on the implementation. So the system is up and running. So you can even go right now, download the application One Bus Away, and you will see Mayagüez. It's right now at a beta stage, but you can see all the system in terms of the rural routes, the bus stops. You can see on real time where are the location of the bus across the system. So we are very close, and we are very proud of this project, because it will be an assistant to users, but it will also help research in the transit topic. So for us, this is a huge advantage, being able to work in NICR in this type of development. I'm already at the end. Two of the projects that we are working right now, very interesting, very recent, related to the pandemic, COVID pandemic. We are working with Texas A&M as well, Dr. Burris and a team from Mayagüez, working how COVID has affected travel, highway travel, transit travel, and we are using technological simulation like virtual reality, galvanics in response to measure how people perceive the risk of being in a transit system. And what about COVID? Are they thinking about COVID when they use transit? Does that deter some people to using transit and decided to use an alternative mode for transportation? That impacts congestion, if we do think about it, because more people might be using their cars because they are afraid of getting COVID if they go into a bus in a heavy rail system. So we are analyzing that, and obviously we will get some data. Another project that is in progress is related to equity and also to improve service areas, more or less in terms of transit as well, paratransit services, scooter services. That's another project we have right now. And obviously, the big topic for today is freeway management. We have this project with the University of South Florida, very promising, of using new technology, drone technology. You have heard about it, maybe for inspection of bridges and other infrastructure. Now we're talking about how we can use this technology to improve freeway incident management. This is a new way of using this technology, learning about it, learning their pros, their cons, and how we can improve transportation management in terms of freeway incidents with the use of this technology. And this is, you will learn a lot about it in this morning. So in conclusion, obviously NICR, this is just a glimpse of what NICR is in terms of Puerto Rico and the collaboration. NICR overall has 17 different projects working along these 4 universities, and we are very happy to be able to assist congestion mitigation across the nation. We are a national institute, so we are very happy to be here. This is the website for the NICR. Go there and learn more about NICR. There are the projects, the research projects. We have webcasts from all the projects frequently. At that direction, you can register. It's a free registration. You can watch the recording of the previous webinars. So go ahead. We also have a Facebook group, but I know I'm running out of time. So thank you very much, and enjoy the rest of the seminar at this moment. Thank you very much.
I'm not sure if we're taking any questions. No,
After
not yet, because, okay, not now, but don't worry. If anybody has any questions, you're going to be able to ask them later. But now I want you to welcome back Adrian Gonzalez from the Puerto Rico Highway Authority, who's going to be talking about the future of the system, the transportation system for the year 2030, if I'm not mistaken. Is that correct?
Yes.
Yes. Hi, Adrian. Welcome back.
Let me see.
Oh, yeah, the transportation vision for 2030 to tackle freeway congestion. I like that word, tackle. Sounds very good. Well,
Perfect.
Adrian, you can go ahead with your presentation.
Let's see. I'm able. Yeah, are you seeing the presentation?
Yes.
Yes, we can.
Excellent. So, good morning all again. Yes, I'm going to be speaking about the transportation vision we have here at PRSTA for 2030, how we're planning to tackle freeway congestion, something that, as you know, nationally 60% of the congestion is caused by non-recurrent causes, such as traffic incidents, inclement weather, work zones, special events, and poor signal timing. Work zones is one that is where we are, as government head of government agencies, getting tackled by the public because there's a lot of congestion given the lots of projects that we're taking into consideration. So we're looking at different ways of how we can improve that. But today, what I'm going to be talking is more kind of like going to give a brief introduction of the principles of highway congestion management problem and the typical solutions and how we're doing it here in Puerto Rico. Some of them that Professor Alberto Figueroa already mentioned. So looking at how that evolution of traffic management doing with the new dynamical lanes from San Juan to Caguas, the traffic management center. I'm going to be going over some of the congestion relief projects that we have in the pipeline here at PRHTA all the way to 2030. So kind of like to set the baseline. I think I'm here. The folks that are seeing the presentation, this is very basic, but for the folks that don't know about it, so we're looking at flow, queue, basically the number of vehicles. So here we see in the above lanes on the top, it is basically a formula of density and space means speed. So looking at the above portion of the picture, we can see the lanes on the top are basically a maximum density, low speed and low flow, and the bottom lanes, low density, medium flow, high speed. So we're always trying, that's what we're trying to do with the congestion management, to remain in this green area here on the left, upper left side of the graph, looking at that speed curve, to have that free flow. And once we're kind of like reaching that maximum flow, obviously the capacity of the section is compromised. So looking at this, we have, and this is a picture of PR18 and PR52 from the 1990s. A lot has changed, but at the same time, same problems are still there, right? So traffic flow is directional. There are significant delays in peak period by peak direction, high level of environmental impact, high fuel consumption costs are hampering us, and the dependence of the individual automobile with 1.2 passengers per car on average. And we cannot look at this as an equation of just adding new lanes, right? And more capacity. Adding lanes is not necessarily the best solution. There are more efficient use of existing infrastructure reversible lanes. We've been doing it here in Puerto Rico. Changes in the network are providing alternative routes. Technological changes like mass transit and bus rapid transit. So we're not just open the DTL. Now in December, we're going to be opening a new BRT, a bus rapid transit lane from Caguas to San Juan to basically help feed the Tren Urbano. And the optimal operations with intelligent transportation systems, like we're doing it with the TMC in Caguas. So we started trying to tackle this congestion problems that we have in Puerto Rico with reversible lanes. In PR18, this when it was basically inaugurated, you can see there brand new equipment at the moment. And we're looking at additional routes. And this I find very, very interesting because you can see there in the green, this is basically PR18 and 52 that we know very well. But back then in the 1990s, there was an idea, and I think there are still conceptual designs here that maybe we can dust. And it was basically a competing alternative route with PR20, basically from Kennedy Expressway in PR2 here in San Juan, PR20, and then expanding PR1 to have that kind of parallel corridor to PR52, but obviously that was not pursued later on. It was left with Kennedy Expressway, making it an expressway, and with PR20. But as I was mentioning, not just providing additional capacity is the solution. So there are different ways that this has been done with, and this IPS is one of those. Here I want to make a parenthesis. I don't know if the one in the picture there with the permanent engineer Lisette Lugo, she always puts pictures of me in different presentations. Here I wanted to say this was her, but I'm not sure if it's her. I know she's there in the public, so it's a joke that we have. We share each other with each other. So in PR26, the Valdoriotti Expressway, most of you, the folks that are visiting from the States, This is the roadway that you take immediately after you exit Luis Muñoz Marin Airport. I probably arrived through there. So we're maximizing the IPS in this corridor with 26 CCTV cameras, 4 variable message displays, 29 radars, 21 Bluetooth readers, and 1 meteorological station. This is kind of like the typical messages that you see there. I'm happy to say that we've used it with a pink. I think it's called a pink alert, similar to Amber Alert when a kid is kidnapped. In this case, it was a lady that was kidnapped. And I like to say that the ITS system that we have in Valdeoriotti saved her life. Her picture was displayed there. The card, I think, was the card that was presumed that she was kidnapped on, and the person that kidnapped her left her very near in Valdeoriotti. So I like to see this not just for traffic incidents, but it can have a broader impact within society. These basically pictures of the corridor. We are also using it, as you know, we have a collaborative MOU with Florida DOT, and we use SunGuide to feed the system. And this is basically what we've done with the DTL here in Mayagüez. Some average speeds of how we've seen the corridor behaving. So basically, when we had the reversible lanes, the average speed in the mornings was 35 miles per hour versus PM peak hours looking from San Juan to Caguas, 16 miles per hour. When with DTL we see 52 miles per hour. I think this is, well, this is the numbers that we have. I've seen people driving way faster in the DTL, and I take a parenthesis here to always invite folks to drive carefully within the speed limits. We want to avoid all fatalities and car crashes. So just it's kind of like something that we should always have in mind. And when we see that improvement from general purpose lanes down here, 22 miles per hour, once we use the reversal lanes, 35 miles per hour, and then inside the DTL, 52 miles per hour. So we see that improvement that the DTL is providing an option, a definite option for users to arrive faster and safer to their destiny. There are definitely other options that we're always exploring. We're always trying to invest. We're together with PRITA, with the Puerto Rico Integrated Transportation Authority, collaborating with DTOP, like Tren Urbano, the BRT that I mentioned before, the bus feeder system that we're trying to create to help increase the usage of Tren Urbano and to Congestions as other options. So here in Puerto Rico, we're definitely very car-centric to have other options that are reliable for users. So for example, the Secretary has several initiatives that should motivate users to enter use more the different public transit systems. So for example, she's working on an app that people know when the bus from AMA is arriving to the stop, so they can, oh well, so I can plan myself. In 5 minutes the bus will be here because I can see in the app where the bus is, and it's telling me the estimated arrival time. So the confidence level of users can increase, and by connection, the usage of the system will increase. So these are, and then this is the San Juan Region Strategic Network. As you see, PR18, PR22, that from 2000 to 2004, there was an investment of almost $500 million there in the system to make it more reliant. And we're still investing in some of the projects that we have on the pipeline. We will talk more about them subsequently. So the evolution of the system, as you can see before, that $475 million investment, PR20 and PR2, the Kennedy Expressway that I was talking before. So basically making an express lane PR2 at Caparra interchange to reduce the PR20 bottleneck, the movable barriers, reversible lanes in Kennedy before expressway conversion, and the Kennedy Expressway becoming a full expressway, and then the improvements to the Caparra interchange. The DTL in PR22 that Professor Alberto Figueroa was mentioning before, there are some projects that Metropistas is considering performing there at the DTL where it ends in Dorado, extending it to prevent that bottleneck that is currently happening there. So there are some projects that Metropista is pursuing as well. PR18 and PR52, as I was mentioning before, we had reversible lanes and movable barriers, and then movable barriers, reversible lanes in PR1 to Caguas Norte, and now the DTL and the projects that we're pursuing on extending that DTL to PR30 that I'll talk about later on. It's a very interesting project. And then the PR26 corridor, and in the next slide I'll talk a little bit more about how the projects that were pursued here that definitely helped with congestion. So first was the Valdoriotti overpasses over Avenida Gobernadores, the Conector 1 and Los Angeles interchanges. Then the conversion of express lane in the North Frontage Road, then movable barriers and reversible lanes, and at the end, the widening to 8 lanes and the improvements to the PR22 interchange. That is where we basically have the current condition of a bottleneck. So this is a picture of Valdoriotti Expressway, PR26 back then. And here in this graph, you can see when it opened, boom, the congestion happened because once it opened, new bottlenecks appeared on the system, and you can see here the time in minutes. It jumped at that peak hour of around 6:45 a.m., 7:15 a.m. Of 38 minutes. Then, and this February 97 when it was open. Then March of 97, when the use of the frontage road was allowed, it went down to 35 from those 38 minutes. The peak time shifted to 7:15. Additional things were performed with flyovers in October of 98. The time, and this is from the Los Angeles Avenue intersection to the Avenida de Diego, and then it lowered to 22 minutes. And finally, in February of 99, with the reversible lanes, it went down to basically 10 minutes. Those peak times of between 6:45 and 7:15. So you can see here the different congestion relief approaches and how they improve the traffic in this corridor of PR26. So now looking at the DTL, so at the beginning, as I mentioned, there was the construction of 2 reversible lanes, PR18 and PR52. They were used in AM, so to the folks that are not from Puerto Rico, so from the town of Caguas, the municipality of Caguas, there's a lot of commuters, Curao and the region of the island, and they're coming to work in San Juan. So you can see that traffic happening from San Juan, from that region of Cagua, Cida, Calle, Curao, moving in the mornings to San Juan, and then commuting back in the afternoon. So that's basically the behavior of that corridor. So here we build that DTL with the dynamic toll lanes to provide free flow speeds of 55 miles per hour. The goals were traffic management and reversal lanes using dynamic tolling, maintain free flow, maintain highway with flow, speed, and density sensors to optimize operations in real time. Something that is to make it self-sufficient is something that we're still working on. Right now, we're providing the tolls ahead of time. So basically, with the curves that the engineers are providing. But the idea is to be completely independent with the sensors, and it will be completely dynamic toll lane as its name provides. And we're looking at improving incident management and allow the BRT, as I was mentioning before, to fit Tren Urbano from Caguas, something that is going to be starting now at the end of December. So this I already talked about this. Well, deployments, it generated 3,200 employees, workers, with 60 million in estimated salaries. It provides strategically located U-turns for first responders to improve incident management. And also project line included for the corridor is a section is already worked on, and we're working the last section from, I think it's from Montelledra all the way to Caguas Norte. We're working on that very diligently to turn those lights on by January of 2022. This is basically a schematic configuration of the DTL. This is the Caguas Norte toll plaza. There's the entrance to the DTL. Interestingly, I don't know if I have it here, but in the afternoons, once the DTL was opened, there was a weaving that happened in the exit. I think I have it later on, but there was a weaving at the end where the DTL was basically collapsing on Fridays. Fridays, a lot of folks, the behavior of the folks using the DTL is very interesting. Folks tend to use it more on the afternoons, and it makes sense because maybe in the mornings they're trying to arrive to their work, they can schedule and they plan on how to arrive to their work. Sometimes they plan not to use the DTL, but in the afternoons they want to arrive home faster. So there's a tendency we see folks to use more the DTL in the afternoons than in the mornings. So going home, they want to arrive home faster. And on Fridays, there was a lot of usage of the DTL once it opened, and it collapsed because there was a weaving that happened once the traffic here of Caguas, basically the reduction of lanes. So what we did was to extend the DTL through that weaving portion of the exit with a reversible lane, and it's been working perfectly as of now, and the DTL doesn't collapse anymore. This is the configuration in Montelledras, where in the mornings there's we're traveling from Caguas to San Juan. There's an exit here in Montelledra, and then in the afternoons, that exit is closed, and then the folks use it in the afternoons to enter the DTL from Montelledras to Caguas Norte. This is the configuration in PR18 where the project ends. Interestingly, right now, where the maximum fee toll that we're charging is $3.50, but the toll rates can be between 50 cents and $6, and the $6 may seem steep. It has a ceiling. It's not like other DTLs that we've seen in Virginia that don't have a ceiling. This one has a ceiling, and although $6 might seem very steep, it's there once we have all the capacities to make it fully dynamic We want to make sure that the users can have that free flow speed of 55 miles per hour within the DTL. So as I was mentioning, we're looking at other construction of how to expand the DTL. This is to PR30, a very congested road here in Puerto Rico. Basically from where it currently ends in Caguas Norte. And here we have some schematics of how this will look like. There's basically a flyover, a bi-directional flyover where we have it currently ending here in Caguas Norte. It will go over that flyover to PR30. This is a very congested intersection, and the DTL projecting all the way through to after 203. So here is the flyover that I was mentioning, providing for new ramps, new PR1 interchange, and this flyover, bi-directional flyover for the DTL. So users of Gurabo, Caguas can benefit from that traffic in PR30, which should improve very much that intersection. This project we're working very diligently to have it up for bid by the second, third trimester of next year, 2022. It will also include an intermodal center. 7 acres for development is something that's still in the design phase, but looking kind of like to create that intersection where folks can leave their cars here in Caguas and go all the way to San Juan, take the tren urbano and do their business away, providing a congestion relief for PR52. This is basically how the DTL was composed or divided. It's different phases. We're looking at over $100 million investment. DTL phase 3 was an investment of $46 million. DTL phase 1, $40.5 million. DTL phase 2, $38 million, and now phase 4 with 14.6, where we're doing all the wiring and that sort of stuff to basically that backbone for the ITS system. And this phase 6 is still underway. So this is how the DTL has been performing since it was open and inaugurated by Governor Luis on April 27 of 2021. By October 31st, basically 1.7 million users, cars had used it with an average of 15,000 vehicles per day. The revenues that it has generated is $3.7 million with an average toll of $2.07. The traffic increased from basically 235,000 cars to 353,000 vehicles per month between May and October, a 50% increase, with monthly revenues ranging from 400K to 700K. So we're very happy with the performance of the DTL. We're still looking at ways that we can do revenue maximizing and improve the user experience. And we're definitely very focused on that extension of the DTL to PR30, where it's gonna not just help the congestion in PR30, improve the user's experience, but also help pre-HTAs in a fiscal and financial way, sense. Also, the Traffic Management Center, something that Engineer Lisette Lugo is very proud of. It started operations in November 14 of 2019. It currently has their presence of police, EMS, and from us, from the Highway Authority, where we have and dispatch the Seguro system. This is the phone number. I believe folks from the universities are going to be there tomorrow. Is that where it's at? Yes, tomorrow. So looking forward to receiving you guys there tomorrow morning. We have their state-of-the-art equipment. All the folks are from the best caliber, and they're working very diligently to prevent accidents by quick responses in the system. So we're there. We have in our TMC incident management, travelers information. We collect a lot of data, performance measures, special events management as well, coordination of first responders, the management of Seguro, as I mentioned before, and the MOT coordination during construction. So basically at the whole system, and it's something that we want to expand beyond the current system. We're from the TMC, we manage basically the Kennedy, the portion of PR2, the Kennedy Avenue, PR20, PR26, 66, Highway 66 as well, PR18 and a portion of PR52. We're looking at ways of expanding it all the way to Ponce in PR52, so we can make that we have that longer reach to prevent accidents and manage congestions. This is basically the slide that I already mentioned before. This is the Seguro network. As I was mentioning, you have PR66, 26 here, a portion of PR1, PR2, this is the Kennedy Expressway, PR20, 18, 52, portion of PR30, as I was mentioning, expanding towards Ponce in PR52. So looking at the transportation vision for 2030, the way I see it here, heading PRHTA, this is kind of like a four-way component. We're looking at the emergency reconstruction program. We're still recovering from Irma Maria. Then we have the regular program with the accelerated highway reconstruction program, the highway congestion relief capacity enhancements. That is, I'm going to be talking about those projects briefly. And then the second part, the latter part of it, is the preventive maintenance with Abriendo Caminos and the PIMOC projects. Basically, in this decade, looking from 2021 to 2030, we're looking at an investment of $4.8 billion to invest of federal and state capex monies for the highway reconstruction and the congestion relief. As I was mentioning, the emergency relief program, it's a $600 million investment that we're doing, recovering with signage, landslides, and 2022 is going to be highly focused on that. The last 2 weeks, we had the bid for we received proposal for the bid for the last highway that we need to basically do the illuminations. That's PR53. So we're working on providing all the luminaries that are missing from Irma Maria, all our highway systems, the tolls highway systems. Then the regular program, as you know, the infrastructure bill that President Biden passed in Congress is going to help increase the funding that we currently receive from the $158 million to 180. So basically a 30 million, shy of a $30 million per year increase in the regular, in our regular federal program. But it also provides for a new bridge program of $225 million for the next 5 years. So basically looking at a $25 million increase per year for bridge repairs and preservations. Additional funding for the National Vehicle Electric Formula projects, and this in addition to state capex that we have in our fiscal plan with the Fiscal Oversight and Management Board approved fiscal plan of $142 million per year of state capex. And to this, we include the CDBG MEET program to help complete the Puerto Rico Strategic Highway Network and capacity enhancements with over $750 million. And we're pursuing other discretional grants where we expect to be successful with another investment of $240 million. These together with basically maintenance projects like Abriendo Caminos, where phase 3 was performed by HCA, now phase 4 is in the final stages of this procurement process in DTOP and with the ISAG to do the procurement for the next and final 4th phase of Abriendo Caminos, which together are an investment of $167 million. So we're looking at a very busy next decade where we plan to invest, as I mentioned, $4.8 billion in the system. So how do we see these projects? As you can see, a lot of them are in the metropolitan area, but we have projects all across Puerto Rico. The first 3 are priority projects for the governor. First one is the PR10. There is a complete that connection north-south between Arecibo and Ponce with a $260 million investment. Finalizing that connection of PR5 from Bayamon to the Tirantado Bridge in Naranjito, $150 million investment. And starting with the extension of PR22, we're currently doing the EIS, environmental impact statement, to reach our target of in late 2023, beginnings of 2024, start that first segment of Atillo with an investment of $250 million. So we have a plethora of projects. This is the PR10. It's basically, to finalize it, it's in the center of the island. We're looking at basically, this project has 20 bridges. So it's basically bridge sections to finalize this highway. This is gonna be a non-tolled highway. The RFQ was published in October of 2021, and currently we are doing the RFC stage in the RFQ process to begin the RFP. It's our target to have it start by the first trimester of 2022. This is the conceptual design of PR5. As I was mentioning, looking from Bayamon to Naranjito, but this is the project that is my favorite project. I think I can have a favorite project as executive director of PRHDA, and not just because I'm from the west side from Moca, or I was born in Mayagüez, but because we have a saying in Colegio de Mayagüez that my blood is green, right? So I'm a proud graduate alumni from Mayagüez, and this is my favorite project. And this is definitely a congestion relief project. We're working very hard to have this project announced for bid in the first quarter of next year. So basically very soon, because we're already mid-December. But this is a very interesting project. This is, to the folks that are not familiar with, this is the entrance to the UPR, University of Puerto Rico and Mayagüez. We're basically having a flyover for the folks that are driving through PR2. It touches upon the 102 intersection, the 3102, closes this intersection in Terrace, than a flyover. We're still doing some micro modeling to make sure the roundabouts are not going to collapse, and they're going to work efficiently. But we're very optimistic and very advanced on those analysis to have this project built out by the beginning of next year. We have other projects, some diverging diamond interchange with ramps in PR52 to do congestion reduction, highway safety improvements that we plan to bid fourth quarter of 2023. We have another congestion relief project here, this intersection of PR28 and 165, PR22, Buchanan is the toll plaza is down here. City View Plaza is around here, so there's a weaving that happens here that projects the traffic all the way to 22. It's going to help very much. This project is going to help with that. So we're getting this project ready to be announced so third quarter of 2023. I already mentioned about this project, the DTL extension from Caguas Norte to Bravo in PR30. And last but not least, another very interesting project here in San Juan, that is the intersection of PR18 with 22 and 17 with 18. So looking at this intersection of PR22, this is where Plaza Las Americas is. A weaving that happens here, basically eliminated with a new bridge, another new bridge here. To basically help with this bottleneck that happens in this intersection. It's a $45 million investment, and basically together with that same project, because these are very close intersections, but we're looking at launching it in a kind of like in a phased approach, working with Piñero Avenue, PR17, that intersection with PR18, where we're basically, as we're doing with DTL in the Caguas Norte, with a bidirectional flyover, as you can see here, because this ramp from PR17 going up to PR18, there's a lot of traffic, and basically it collapses. So working with that, basically with the DTL bidirectional flyover to increase that, while at the same time providing this new bridge to increase capacity and help with the congestion in this section of PR18. There are other projects that we're working on. As we this year, one of the achievements that we were able to do together with FOMB was explain to them how we need soft costs to basically put together projects that are shovel ready. And as we identify the funding, we have basically the projects ready to go out for bid. And these are projects that we're currently working on to do congestion release initiatives all across Puerto Rico. As you can see, we have Conditional Management 9 projects in PR3. We have projects in PR2, La Avenida Corazones in Ward 14 to do that expressway conversion all the way from Mayagüez to San Juan, basically. And then last but not least, that Congestion Management 14, then extending the DTL, not in Caguas, but at the latter end, from where it ends basically to Plaza Las Americas. So together with the projects that I mentioned before, they're gonna definitely help with that bottleneck that is happening right now with the Piñero Avenue. So with this, I end my presentation, and thank you all for your attention.
Juan. Alrighty, thank you so much.
Irmali, perdóname, no escuchamos nada de parte de allá del salón.
Okay.
Ahora
Okay,
sí,
hello,
gracias.
We're so sorry about the delay there. We have technical difficulties. Thank you so much, Eddie, for that presentation, and do not feel bad for the Vita intersection being your favorite. I mean, it is the best project. So, and it's not because there's green blood through my veins. So we have maybe 2 minutes for questions. And I know there's already a question for Dr. Alberto Figueroa, but I wasn't sure. It's about the prototype. I'm not sure they're talking about the open bus. Cristel, if you're over there, can you please, or somebody tell us the question from the chat?
Yes. Thank you, Dr. Cruzado. The question is for Dr. Alberto Figueroa. How often will the data be updated in the prototype? Will the results be live on the same day? And how many times will new results will be uploaded? Sorry.
Okay, thank you for the question. That allows me to expand a little bit. That project from NICR we completed last summer, and as a project during the summer, we had 2 students from software engineers that assist us to develop this tool. This is a traffic performance dashboard for PR22, and we use the data that we have for year 2019, and we created this dashboard as a prototype. So we can show that to the freeway operators, the highway authority, so they can see the potential that this type of tool has for both the operator of the freeway, so they can understand the data, see trends, and analyze what is going on with the system and can make decisions how to improve it. And the other benefit of this type of tool is that it can use as a traffic information dashboard for users that they can. Those who want to know information on how the freeway works can go and check traffic speeds, traffic counts, at what time the highway operates better. We saw an improvement in travel time of about 7 minutes in peak hour traffic with using the DTL on PR22. But at different times, it depends, it changes. So this type of tool for those people who wants to have the information is very useful for the user. So we showed that as a prototype. Actually, it's not live right now. We use it as a potential product that this project has, and it can be developed in a formal way using real-time data that the operator can input to the system and can be obviously online on the web. So obviously, it's a product that we are showcasing as a prototype. It's not like the case, for example, I'm going to take the opportunity, one bus away. You can go right now to any Android store or Apple, and you can download. That one is actually on live. We are waiting, obviously, with the actual launch of the prototype of the application. But that one is operational. That's one bus away. You can download right now and see how the system is performing. But we are in that process, and like I said, we as a research group, we develop this type of products, technological products that can be used to information, research, and obviously to improve the efficiency of the system. Thank you very much for the question.
Grisel, it is my understanding that there are no more questions, and it's perfect timing because we're going to take a break now, 10-15-minute recess. We're scheduled to continue at 10:30, okay? Thank you, everybody.
Muchas gracias a todos los que están participando en esta cumbre virtual. Comenzamos un receso de 10 minutos. Regresamos a las 10:30 de la mañana. Muchas gracias por estar participando. Buen día.
Okay, welcome back, everybody. We have our next presentation is going to be a joint presentation. Engineer Josué Cruz Martinez, who did a bachelor's degree in industrial engineering and has worked at the PRHA team. But now, for the last 2 years, he's been working at the consulting firm CMA, and he's going to be presenting with engineer Ashley Vargas, who has a bachelor's degree in civil engineering, and right now she's working at Matrix Engineering, and their title of the presentation is Innovation in Transportation, Crowdsourcing, Next Generation CIM Team in Puerto Rico.
Thank you.
No, lo pasan aquí, pero, ¿sabes? No sé cuándo pasa, pero por aquí.
Can everybody hear me okay? So thank you, Yvette, for presenting us, and thank you to all the organizers for inviting us today to present a little bit about innovation in transportation, specifically for crowdsourcing and next generation team in Puerto Rico. So I'll start with a timeline discussion to put in perspective the TISMO program implementation. Basically, the executive director talked about the DTL project, Seguro, and the TMC operation. So I would like to all of you that see in perspective that from 2010, Josué started with PRHD as a dedicated internal resource. Now he's a consultant providing services for the TISMO program oversight. And then in 2010, also Puerto Rico hosted the Central American and Caribbean Games in the West area. That's close to the Mayagüez, the PR2, close to the University of Puerto Rico Mayagüez campus. So in that event, PRHDA worked for the traffic management. He was they were co-located with police at the same center. And then in 2013, that's a photo of myself. Now doing a hobby like the Josué's photo. That was from Utah doing mountain biking, right? But in 2013, PRHDA hired us as consultant for the ITS program. Basically, we were in charge of developing all the system engineering documentation, including the ITS architecture update, including the program management plan, the high-level system requirements development, and so on. So in 2016, PRHDA started with the TMC operations, including incident management. In that year, we were located at the Mayagüez Government Center at the 8th floor. And then in 2017, started the Seguro program. That was a big achievement because the PRHDA advanced from the traffic monitoring stage to a response stage. By providing this service, we now have in the TMC, we now have direct resources that can respond to incidents. Now, then in 2019, it was a very big year for PRHDA and for all the travelers because the new state-of-the-art TMC was inaugurated, but also the first ITS project in an express lane here in the San Juan metro area, being the Pier 26. That's the main corridor that from and to the international airport. So it's very important corridor in San Juan. And all the equipment, the ITS equipment installed in the Pier 26, including CCTV cameras, NVDSs, Bluetooth, dynamic message signs, and a road weather information system are fully integrated with the TMC. And this year started the ITS preservation contract for the Pier 26, being the first preservation contract for an ITS project. And as the executive director mentioned before, of the inauguration of the DTL for congestion management. Seguro basically consists of, it started with 13 units in 2017 in the main express expressways in the San Juan metro area. And then the second phase started in June 2018 because of the benefits that this kind of program has. Then the third phase was then again expanded in December 2019, including the PR 30 extension and the PR 66. In the map, you can see the black line. That's the extension in December 2019. We now have 70 units, but with the new contract, PRHDA will have 20 units in this same area to provide for more coverage. All that coverage is around 75 miles of coverage. And as part of the ITS program plan, PRHDA prioritized the ITS deployment within the Seguro area. Why? Because it's the expressways and freeways in the San Juan metro area, excluding the PR 22 that is operated and maintained by a private operator. So with all these ITS deployment and devices integrated with the TMC, we'll have more information and more tools for incident management and traffic management overall. In 2019, with the opening of the new TMC, PRHDA was able to obtain SongGuide. SongGuide is the same advanced traveler management software that uses Florida as part of their traffic incident management. So we use SongGuide where we are able to integrate all the ITS devices. We also integrate here Seguro. We are able to see Seguro, the location of Seguro and everything else. And also they have a SPAR. SPAR is a mobile application that can be accessed from any cell phone or tablet. And every incident that Seguro is assistant to, they can create the event, and then automatically it is published here in SongGuide. So the TMC staff are able to monitor the incident and include more details about the incident. Then, like when the service patrol create the event, then the control passes to the TMC operators, so they can focus on the traffic incident management services. So basically, we collect a lot of data about the incident timeline, response time, clearance time, roadway clearance time. But we also collected data about the average service time for disabled vehicles incidents. In this case, we can see here that if there is no need of a tow or private assistance to clear the incidents, it's basically when there is a need of a tow, there's a double of time. So there's something that we can do about that. And that's what we can do with the data. We can visualize where the problems are and then take decisions and with other stakeholders and stuff. So there are disabled vehicles. We have disabled vehicles with battery, with no gas, with overheating. So that counts for approximately the 15% of all the incidents. So that's an important data, so we can do and then improve the program by selecting some strategies. And here we can see how the traffic incident management program has evolved during the years. For example, in 2012, with the first team self-assessment, we had 6.7 at the very beginning of the program. Then in 2015, we jumped to 43.10% in progress. So there's a lot of commitment, not only from the PRHDA, but from all the stakeholders. And then you can see from 2017, 2019, a constant progress. That tells about the commitment. And that's why we are all here. Now I'll turn it over to Josue, who will be talking a little bit about Everyday Counts initiative.
Thank you, Ashley, and thank you all for inviting us to participate here today. We will provide you like an overview of the Everyday Counts program and how that program has aided the PRHDA in moving forward with the implementation of innovations. I don't know if you're familiar with the Everyday Counts program, but this program, I will call it EDC, the EDC program, its goal is to promote innovation so that states can implement them to shorten delivery time, reduce congestion, and also improve safety on our highways. In terms of reducing the congestion, we know that 60% of all the incidents or the congestion is related to non-recurrent congestion, and that non-recurrent congestion includes traffic incidents, weather events, poor signal timing. And with the ADC program, we are trying to innovate and try to address those problems that are causing non-recurrent congestion. Here are some of the innovations that the PRHDA has adopted through the years on all the ADC rounds. We have the National Traffic Incident Management Training Program. We have using data to improve traffic incident management. We have also crowdsourcing for operations and next generation team that it is the one that we are on currently. Thank you. So in the first one was National Traffic Incident Management Responder Training. That was on EDC2. Right here we can see a map of the implementation nationwide, and in the arrow you can see the percentage of people or responders trained here on the island based on a goal that was established by the PRHDA. So we are right now on 74% of the incident responders trained. We are meeting the goal that Federal Highway has stated for that particular initiative, that right now it is on 55% training. So we are right now at 74%. On the table below, we can see that we have performed 5 train-the-trainer sessions. During those train-the-trainer sessions, we have persons from the Federal Highway come here to train other personnel so they can train others here on the island. And most recently, those train-the-trainer sessions have been performed with local incident responders here on the island. So far we have 234 trainers trained, and then other data. So we are right now ranked number 6 on the nation in terms of meeting our goals on traffic incident management training. On the right side, we can see like a photo of here in front of the College Engineers and Line Surveyors of Puerto Rico, one of the trainings performed here on the island. Next one, we implemented using data to improve traffic incident management. That was part of PDC4. As part of the activities performed, we developed an app for the Seguro program so they can collect incident data. Those are the screenshots that you see at the right side of the screen. That was before we had Songai, so that was a need that we have to collect data. We didn't have an TMS at the TMC, so we developed an application so that the highway safety patrol operators can collect the data and transmit it to the TMC. Also, as part of the Everyday Counts initiative, we participated for the STIC, the Statewide Innovation Council funding, and we were awarded some funds, and those funds were used to purchase servers and equipment for the TMC, so we can prepare for the implementation of the song guide in the future. And as part of that effort also, we started performing the song guide training for the TMC operators. So when the time came, they were prepared to start using the song guide on the TMC. And here you see some of the dashboards that the TMC operators saw previously before implementing song guide. That was part of the app developed. It was a web-based develop. So you can see what the TMC operators saw on their screens, and also the data that was collected. This innovation was highlighted as part of the Federal Highways final report as a success story for the implementation of this initiative, and it also was key in keeping the operation going during the impact of the Hurricane Maria. So if it was web-based and cellular phone, they could perform the data collection even on those tough times. Another innovation that we performed on the last round of EDC was crowdsourcing for operations. During this implementation, the activities that performed was that the PRHDA executed an agreement with Waze, so we can share data with Waze and on the incidents that they are collecting and the incidents that we are also collecting. We developed protocols so that the TMC operators can use the Waze tools as part of their everyday job, and also we perform the integration between SunGuide and Waze so that we can push the incidents that are managed at the center with with SunGuide to Waze automatically. Right here, we can see some of the tools that we are using with Waze. On the top left, that is the traffic view that is used at the TMC so that the operators can detect incidents on the roadways, and that is key because we don't have a lot of ITS coverage. So with that tool, we can detect incidents with Waze, and then the TMC operators can dispatch units so they can verify if there's an incident and send the response and coordinate with other stakeholders. So if we didn't have that tool, we have to wait until the Highway Safety Patrol went and saw the incident and then report back to the center. So right now we're using Waze for incident detection. On the bottom we see the tool that you use to inform users of road closure. So then when they are using the Waze application, they can see that the road is closed, and then automatically Waze recommends detours or other actions. And on the top right, we see the Waze map. All the incidents that are managed at the TMC, they are entered automatically on the Waze map, and the travelers can then get the data from the application automatically. And this on this round, EDC6, we also keep going with the crowdsourcing for operations, and the activities that we are performing is explore further use of the Waze crowdsourcing data at the TMC on Google Cloud, so we can use that data and perform analysis. And also we are exploring the use of Freeways for the TMC. Here are some of the tools that we have been evaluated to implement on the TMC with Freeways. On the top left, there's a map that integrates all the information, all the CCTV cameras, performance measures in one screen. Then on the bottom left, there's an incident timeline that we can use to evaluate how the road network was impacted through several or incidents. Then on the top right, we see the detector health that will be used to monitor the health of the detectors and see if they are reporting valid or invalid data, if they're communicating, and with that we can perform or call the ITS preservation contractor to go to the site and verify what is happening with those detectors. And on the bottom right, we are seeing the intersection analysis tool from British. So that is what we envision moving forward. We are right now managing freeways, but the next step will be manage arterial corridors and trying to optimize their operation. And with in next generation team that is part of this round, we are trying to coordinate sharing the TMC video with the police so they are aware of the incidents and can see them before they arrive to the scene, so they can get additional information and dispatch resources as needed. We also coordinated with EMS to get CAT data into the TMC, so that is another source of data that we will have available at the TMC that we will enhance and improve the operations and incident detection through another means. Also, we are establishing establishing protocols and training for the UAS use for accident reconstruction. The importance of that use for UAS is to reduce the exposure of the police officers when they are investigating fatal or fatal crashes on the roadway. So that is key to keep them safe and keep the roads less congested, because sometimes here in Puerto Rico, when they perform accident reconstruction, they close the roads, and that is a cause of congestion as a non-recurrent congestion. Sorry. And finally, we are performing demonstrations to how the UAS can improve traffic incident management. There is a video of activity or exercise performed during Crash Responder Safety Week. So, Imali, if you can play the video so they can see what was happening there. So right now we are seeing an overview of a traffic incident scene. It was an exercise. It was not a live incident that happened. So right now you're seeing the different components of traffic incident management, and on the back we have the Seguro units providing safety with the cones and also with the flashing arrows. We also have the police following the Seguro. Then we have the fire truck that it is positioned in a strategic form to protect the incident responders that are providing help. The shadow vehicle, and then on front we have the vehicle that is involved in the crash, and next we have the ambulance. It is also strategically placed so that when the people from the involved in the accident are removed and need to transport to the medical facility, they can do it in a fast way, and there's no vehicles blocking the exit of the ambulance, and it is also being protected by the shadow vehicle of the fire truck. Then we have other responders that here help us in Puerto Rico during traffic incidents, such as emergency management or other units of the PRHDA. Yeah. So with that, I think I am done. I would like to stress, right, that the importance of having the university and the DOT and the private sector collaborate on this on managing traffic incidents. The importance of teaching the students and getting them involved early on with the TISMO, the transportation system management and operation concepts, so they are aware that this area of the transportation is growing, and there's a need for the workforce of the future and the data that we need to analyze and all the components. So I really like to stress the importance of involving students and getting them on board and having access to this information and tools and data. So with that, I am done. I think we are leaving questions for later. Thank you all and have a nice day.
Yes, there is a session of questions after 2 more presentations. We are doing actually very good on time, but if you have any questions, especially for those in the webinar, you can type them. You can type them, and we'll get back to them after our 3rd presentation. So now we're going to welcome Dr. Ju Zhang. Excuse me, 1 second.
Yeah, 1 second. We will have our second keyword for the day is innovación. La segunda palabra clave del día de hoy es innovación.
Okay. So Dr. Ju Zhang, we call her Dr. Juju, and she's a professor at the Department of Civil and Environmental Engineering at the University of South Florida. As you can see, she leads the Smart Urban Mobility Laboratory at USF, and she serves as the PI of the Center for Transportation, Environment, and Community Health at US DOT Tier 1 UTC. Those are a lot of acronyms. So the title, and it's extensive. The title of her presentation is Artificial Intelligence Applications in Traffic Management Using Video and Thermal Images Collected from a UAS platform. Welcome, Judy.
Thank you very much. Thank you very much for the introduction. I'm very glad to be here, and I listened to so many impressive presentations already, and fascinating about the next generation transition traffic incident management. So for us, we get this opportunity to work with the University of Puerto Rico on this project. But before I get into that, I want to give a very brief introduction of the Smart Urban Mobility Laboratory at USF. So we have these 3 major research areas. One is aviation, and second is the emerging technology and service mode. Another one is transition resilience. And in the aviation, currently we work on the unmanned aerial system related research, including the one that I'm going to discuss today, which is application UAS in traffic management. And also we look into, past planning for the multiple UAVs and the safety assessment of UAV operations. And another area in aviation we're working right now is advanced air mobility and urban air mobility. So to use another name to call it like air taxi, on-demand air taxi. So we look into the design, the trajectory planning, the traffic information services, etc., etc. So I want to acknowledge for the presentation that I'm going to give today. I want to acknowledge our team members. First is Achilles Cutlass, and he's a co-PI from USF side on this project, and he's assistant program director of ITS Traffic Operation Safety at Qatar. And also Mr. Joe Post, and he's a visiting professor of practice, and he served as the director for the system modeling and system at system modeling and analysis at FAA, and he's currently on sabbatical at USF. And also have Huan Tan, he's a PhD candidate working with me, and Christina Curry, and she's actually a master student from business school. And we also have Brian Porter, and his daily job is at the FDOT District 7 office, and he's part-time MS student at USF. So in this presentation, I know that I have limited time. I want to first briefly introduce the unmanned area system, our research scope, and also the research questions that we try to answer. And then for this study, actually, we have multiple phases. So we just finished the phase 1, and we're going into the phase 2. So for phase 1, I will go through the literature review, experiment design, detection algorithm, etc. And for phase 2, actually, is ongoing. We just started, and I want to share some of the findings and also what will be the next steps. So we are already familiar with this traffic incident. I want to mention is some methodologies that I'm going to present later, not only just for incident management, but it's more for general traffic management. But as our executive director mentioned, it's a 58 hours annual, which is a delay. And a lot of that delay actually caused by the non-recurrent congestion, right? So the traffic incident is something we want to mitigate, and we want to remove them as soon as possible, that do not let it cascade into the other parts of the network, and also do not lead to the secondary incidents and more loss of the lives and economic impacts. And currently, we have the patrols going around and try to identify incidents. We also rely on the second reporting. And now we have next generation. We use the drones or other technologies. And also, a lot of the corridors have a lot of the ITS devices installed. And with that, actually, there have been studies looking into predicting the incident even before it occurs. And for the UAV or UAS, it's including the UAV, which is unmanned aerial vehicle, or sometimes we call it Juan, and also ground-based controller and the system, the communications with the UAV. And sometimes in our study, we also include the sensing equipment that's carried by the UAV. And overall, we call it UAS, Unmanned Area System, that can help us to perform the tasks that we would like to do. And then using this UAS, we can actually, rapidly and autonomously look into the large section of the roadways. It's not a fixed station, but it's a moving station with the different speeds. And it could supplement the existing roadside facilities that are available already. It also could play a very key role in the areas that we do not have existing infrastructure. And also in our study, we look into both the RGB sensors and also the thermal sensors, because the thermal sensors sometimes work better, during the night, during the weather conditions that's not so suitable for the RGBs. And also in the phase 2 of our study, we want to look into real-time automated incident detection. So rely on the artificial intelligence methodologies that we look into. So as I mentioned, this is a collaborative research between USF and the University of Puerto Rico, and it's sponsored by NASA, and it's 2 phases. So in phase 1, we focus on selecting and refine image processing algorithm and quantify the performance of all systems. So we look into different parameters and then to see under the different combination parameters how the algorithm would work. And in phase 2, we want to develop a real-time incident detection algorithm. We select the sensor, and then we explore how the outcomes of our study actually could be used by the practitioners, by the TMCs, by the traffic incident management team. And after my presentation, Dr. Crucci will give a presentation, and he will give, different aspects and showing some of the emphasis that Puerto Rico actually worked on. But we did have collaborative efforts on some of the similar tasks. So what are the research questions we want to answer? For phase 1, we want to look into the current status of application of the UAS in traffic management and incident management. And we want to summarize the state of the art of the vehicle detection algorithms. And then also when we look into the door sensors, we want to understand, can the thermal image work comparably well as RGB images in detecting vehicles for fixed or moving stations? And in that, we want to look into how we can design experiments to collect the data and how we can evaluate the performance of the detection algorithms. And for the phase 2, we look into the state of the art of the incident detection algorithms. And we want to understand what are the input variables of these different algorithms and how we can obtain these input variables from the images that we collect by using the UAV platform. And then the next one is how the research outcomes could be used by the practitioners, by different stakeholders. So I will go through very quickly these literature review outcomes. We did a thorough review in terms of the published document, the references, and we summarize application of drones in the traffic management, not only just incident management, but also including monitoring, collecting data, etc., etc. And also we look into the references comparing the RGB and the thermal cameras and images, and look into the limitations of RGB and pros and cons of the different sensing technologies. And we also collected the references and summarized the vehicle detection algorithms. So you can see that there are different categories. The first category is a background subtraction-based method, and the second category is machine learning, and the next one is a two-stage deep neural network, and the last category is a single-stage deep neural network. And all of them, all the other three actually could be considered as artificial intelligence technology. And we see that in a background subtraction only for the stationary, which is the cameras are fixed somewhere, either on a pole or carried by UAV, but fixed at one location. And for the other machine learning, it could be used both for the stationary and the moving stations. And there's a pros and cons listed in the table. And I believe that the slide will be shared later, so you can see the details. Okay, so after summarize all this literature review, we want to come up with experimentals for collecting the data, and then we look into the different parameters. When we look into the UAV, the drone, we want to test the different heights, and we also want to look into the different azimuth angle, and also the depression degree as well. So if you look at the figure on the right side, it shows illustration of how the drone actually will be parallel with the freeway and with the different parameters. So in our study, we actually didn't let the drone fly over the traffic. We actually flied along the road about 100 feet away from the boundary of, from the edge of the road. Okay, so in the phase 1, when we look into detection algorithm, we focused on the stationary data collection. So that's why we use the background subtraction-based approach. And here's an illustration of that approach. So we input the frames, and we apply the Gaussian mixture-based background and a foreground segmentation algorithm, and then we go to the transformation. And then we do the contour generation, we do the contour area threshold, and we do the bounding boxes, and we get the data. And meanwhile, we also manually obtain the ground truth and try to come up with the performance metrics and to compare how the metrics, how the algorithm performed with the different combinations of the parameters. So here are the performance metrics that we used in the phase 1 study, including both precision and rapport, and also F1 score that combining the precision and the rapport. So while we selected the starting sites, we first look into the airspace, and with we have an aviation expert on our team, which is Mr. Joe Post. So he's also a pilot, by the way, and last Friday, actually, he flew us around, me and my son, over our community, which is a very nice trip. So we looked into airspace. We know that in Tampa, we have Tampa International Airport, which is the number 35 airport in the US, and it has a Class B controlled airspace around the airport. So that's why we select one location that's out of that controlled airspace, which is circled red on this map. And we also look into historical crash data by Brian Porter and his work at District 7, so he got the data easily to identify freeway sections with high historical crash sites, crash rates. And then we identified very small freeway segments, because remember here we focused on the stationary data. So we actually conducted quite a lot of data collection. We did, in the phase 1, although our analysis focused on the stationary data collection, but we collect the stationary, we collect the moving stations, with a different speed, 5 miles per hour, 10, 15, 20 miles per hour, with different heights, different angles, etc., etc. So here's some outcomes from our study. We used the door sensors. So on the top is RGB, and at the bottom is the thermal. And you see that the 50 feet, 100 feet shows the different heights of the drones. And also we applied the background subtraction-based algorithm, and it shows the green boxes shows the detected vehicles. And we applied the algorithm to different data sets, different videos that we collected. And here's a summary table showing, for different height, different angle, for southbound and northbound, how the performance matrix will look like. And it's a big table, it's hard to read. And as I mentioned, we also put everything into the F1 score, and we did histogram, so which is easier to understand. So for the histogram, this is F1 score shows the RGB on the top, on the left, and infrared, the thermal images on the right. And then at the top is the southbound, and at the bottom is northbound. So these are the data shows the F1 score, and of course it's better when it's get close to 1. And we find out that most of the time the 50 feet height didn't work very well, and 100, 200, or 300 feet actually works better, even 400 feet. But it also dependent on the degree. There's a green one shows 45 degree, blue is 90 degree, and the yellow one is 135. So we found out for the 90 degree, most of the time it does not cover larger area and leads to low performance, especially for the thermal images. So background subtraction-based method can achieve good detection performance on RGB with most of scores around 0.9. And but with the thermal, it shows more variation from the different azimuth angles. So we found out that the poor performance of the thermal image is because the infrared images are more sensitive to noise, which affect the precision. To reduce the noise, the threshold on the squad Mahalanobis distance could be increased to improve those noise background, which will improve the precision, but inevitably impacts the rapport. So we need to achieve the balance between the precision and rapport so that we can get the best F1 score. And we found out the detection, the subtraction-based method has a potential to outperform the RGB image for the thermal image if the camera is stable with less noise. And we are actually working on minimizing noise, not only just for the background subtraction algorithm, but later I will show we start to look into moving stations. We're using a learning model. We are developing a learning model. So this is the phase 1. And in the phase 2, as I mentioned, we want to look into the automated incident detection algorithm. And from the literature review, we found out that there are 2 different types. One is a microscopic, which is trajectory-based. You need to detect the trajectory of the vehicle first, and then come up with some algorithm to detect the incidents. But there's another type is a macroscopic algorithms. So it did not look into the individual vehicle, but more focused on the volume, speed, the average space speed, occupancy, or kinetic energy of the traffic flow. So this slide shows some description of the different terminologies that used in the incident detection algorithm. And we also found out there are, along all these years, actually incident detection algorithm started in 1970s. So along all these years, there are different based algorithms. One is a pattern recognition based, the representative ones, a California algorithm, or another one is all-purpose incident detection algorithm. And they use the upstream occupancy, downstream occupancy for those algorithms. And they also use upstream speed and downstream speed. And most of the time, they use the data from the loop detector. And the second category is catastrophe theory based. And the representative one is a McMaster algorithm. And they also use the data from loop detector and use the speed, volume, and occupancy could be based from just a single detector. And the performance is that we found out it's difficulty in nonlinear data, which is if you have a lot of the stop and go traffic, then it's not so easy to detect the status of the traffic and draw the conclusions. The next category is the statistical method, and there are a bunch of them, from 1970s to 1990s, and also dependent on the route detected data. And usually this statistical method works better than the pattern recognition-based method. But same thing, it's difficulty for the nonlinear data. And the next category is more artificial intelligence related, including the machine learning and also the deep learning, started from 2000s. And rely on the loop detect data, radar detect data, video, and also data collected from drone. And for the macroscopic algorithm, they use the traffic volume, the speed, and also the occupancy. And they also could look into the time headways between the successive vehicles. And also they take into consideration the road geometry and also the weather. And comparably, this artificial intelligence methodology actually work better than the statistical methods, and it could work for all different types of data. So, for applying those artificial intelligence methodology, we actually have to extract the data from this RGB or thermal images. And one of them is that we need to separate the different direction of traffic. As the presentation showed earlier, the traffic at the different directions actually are very different, right? On one side, it could be very congested. On another side, it could be very free flow. So we also find out that there's a method actually we can use to separate the traffic in different directions, and also obtain the occupancy and also volume from the drone collected data. So in terms of learning model, firstly, we used some available model that actually training using the public available parking lot data, but it didn't work well for our freeway. So then we start to label our frame by ourselves, and After that, we found out even using the RGB labeled data by training the learning model, we can also use that for the thermal image. So the next slide shows the performance of our trained data for detecting the vehicles at the different heights with the different angles, camera angles. And also, this is showing at more congested condition. So we have a drone actually flying along a congested area. And it also, with the trained model, it could detect the vehicles very well. And we use the same model trained with RGB labeled vehicles to detect the vehicles from the thermal images. And it's going to work well, when it's closer, but at the bottom, we see that we need to have the bounding box to restrict the detection area so that we can get good performance. So this is still ongoing effort. So our next step is we need to improve our model by labeling more images and also automatically put the bounding box to improve the performance of detection, and also apply the method in the references to distinguish the directions, and then to obtain the other variables that can be used as inputs for the automated incident detection algorithms. So we are working on that, and we are collaborating with the University of Puerto Rico, and also hopefully to get the help from TMCs, both in Florida as well as in San Juan. And because we want to do the validation as well, so we need to obtain the data when there are incidents occur, and that is pretty challenging. So hopefully we can get the assistance, and we really appreciate that. Yeah, so we also hope that with this summit and maybe with other venues, we could obtain some feedbacks from the practitioners, and then it can help us to look into how our outcomes could be really used by the incident detection and management team and all the other stakeholders who are interested in using the outcomes. So I think this is all I'm going to share today, and thank you very much. And I have my email address here, so feel free to contact me. Thank you.
Okay, again, if there are any questions for Dr. Juju, it's going to be after this next presentation and the last one until, for the morning period. So now,
Before we continue, let's give you the third keyword for the day. La tercera palabra del día, artificial intelligence. Artificial intelligence. La tercera palabra clave. Gracias.
okay, and that one has to be written in English, otherwise no Spanish, right? Okay. So now, once again, we're going to welcome back Dr. Colucci, who's going to be talking about the innovative freeway management in Puerto Rico using drones. And in Puerto Rico, that's with Dr. Colucci, as you know, the professor in civil engineering. I also want to, among the many things that he does, he's also the director of the Puerto Rican Transportation Technology Transfer, what we call Tech Cuadrado, T-Square. And he's the Albertis Chair in Puerto Rico. So let's welcome Colucci. Remember, if you have any questions, it's going to be after this presentation.
Thank you very much, Dr. Cruzado. Buenos días. Good morning to everyone. Before I give my presentation, I want to acknowledge the team, a representative from each one of the team. Dr. Juju Shan is coming here. She's my counterpart at the NICR 4-3. Please come to the front. We also have Dr. Alberto Figueroa, who is the NICR UPRM program manager. In USF, is Dr. Sean Lee. He's connected. Lee, good morning, and thank you that you are with us here. We're bringing the Executive Director of the Highway Transportation Authority, Dr. Adrian Gonzalez. He's our partner collaborating, providing information. We also have on the private sector metrics engineering, please. So we're having representatives in metrics engineering in Puerto Rico that are collaborating and assisting us, and tomorrow we'll be at the TMC. We also have Federal Highway Administration, Michael Avery, as representative Juan Carlos Rivera with us. And this is the team. And also we have visiting professors from other universities. We have a Porter, he comes representing the FAA, please comes to the front. This is a representative group, so you will know that together we made the difference. Like I mentioned, the principal investigator is Dr. Charlie, he's connected. And we're going to take a group photo, so you will remember all of us together, like I mentioned all the time, together we made the difference in improving freeway traffic incident detection in freeways and improving overall safety. Therefore, we're going to have a group photo. La gente que está tomando el adiestramiento, sepan que este es el equipo en un futuro para el manejo de incidentes que van a ver revolucionando cómo se debe atender esta parte que es tan crítica en la seguridad vial de la infraestructura. Vamos, we'll have a group photo and then we will continue. One group photo. Okay. Thank you very much. Un aplauso a todos ellos. Buenos días. Well, Merry Christmas and Happy New Year to everyone in Puerto Rico, in the United States, and everyone that is attending the virtual part of the seminar. Most of the information that my friends have provided is pertinent to my presentation, therefore I'm not going to repeat information. We're going to start with my first slide, please. The title of my presentation is Innovative Freeway Management in Puerto Rico Using Drones. And I want to acknowledge the entire team. Here with us, in addition to the ones that were present with me for the group photo, we have Arcelia Stortelis, she's the copy eye with Dr. Yuyu Chan. Please, Arcelia, come to me here and Arcelia, just you, come. Arcelia is the copy eye, and needing a group photo with Arcelia. He's from Cyprus, and Joseph Poss is a consultant representing the FAA experience. Juan Lotan and is a PhD student that was mentioned by our friend Yuyu, and Brian Porter is a research assistant master student, and Ketana Yachuri from India, also research assistant. This is our team. Dr. Alberto Figueroa is the co-PI here with Yvette Cruzado. Yvette Cruzado will step in as the PI in January, and I wish her a lot of luck. And she's an expert and passionate in transportation. Dr. Didier Valdez, David Gonzalez, our co-PI. David Gonzalez represents our expert in experimental analysis, and the two graduate students are Brian Ruiz and Ruth Rivera. Go here, one photo, and then we will continue. Go. Here, don't get it. Imali, or who's going to take the photo? La foto de copiar. Bye-bye. Okay. Okay. Now let's continue. Next one, please. Then our students. This is Brian Ruiz and Luz Rivera. They did all the hard work. My presentation, everything is thanks to them. Everything this is correct is their job. Any minor thing is my fault. When we started from scratch, none of us knew anything about 14 CFR Part 107. As part of the process, we took the training course with Puerto Rico Drone Academy. We took the FAA exam, and I'm glad to inform that the three of us passed the exam. And they decided that they don't want to show my number, but you know, has a 19 in some place. Okay, therefore, the three of us. Next one, please. Already, you mentioned, Dr. Sang, that we're working together. This is a collaborative work, okay? And therefore, there's similar photos. She emphasized the detection, vehicle detection algorithm. Remember that. And all the literature review was on the vehicle detection algorithm. She did also the comparison with the thermal images and the RGB. And she's saying about next stage is the fine tuning of the box that we need to know in addition to, and Juan Carlos knows that when he was my graduate student, Juan Carlos Rivera, is not only to detect vehicles. We have a mixed traffic stream. We have semi-trailers, full trailers. There has to be count and classification, vehicle count and classification. We need to find a way to detect that there's a vehicle and there is a truck. Okay? And they're working on that. Then, but something that we found out that doesn't matter how much is going on these last 2 decades, the secretary said, the executive director, and it's very pertinent that we found that there was no protocol for traffic incident management. You see a lot of inspections, you have a lot of consultants that do bridge inspection, people from geotech, but we need to establish a protocol, and that was part of our phase 1 in Puerto Rico, a protocol divided in 3 stages, like road safety office, to have a protocol prior to doing the flight test, during the flight test, and after the flight test. And that's part of the contribution of our first phase of our project. And also, we need to analyze effectively in terms of, we're transportation engineers, peak versus off-peak, day versus nighttime. And she mentioned some of the variables. She mentioned drone height. She mentioned the problem at 50 feet that we have with drone height. And she mentioned the problem that we have with thermal images. We have to do the fine tuning. And there's a lot of noise there. And she mentioned also the camera angle. Also, we need to integrate that information with real-time incident detection. And that's why we have our champions from Engineering Puerto Rico and the TMC and Highway Transportation Authority to provide that valuable data so we can do that integration. That is shown in a video that we were lucky to see. I mean, we saw an incident real time at 6:43 in the morning. You can see the queuing that was at 6:53 in the morning, Monday, November 29th. That was not because Ben Colucci was there, I apologize, or because the executive director was there. It was at 6:53 starting the DTL, PR 52 north, and you can see on the horizontal curve, show that video, the lower one. You can see the rest of the queuing, and we're going to show you some statistics of what we can do with this information. I mean, we were lucky to have the drone at that time, so we can get that valuable information. Therefore, we can integrate the drone to assist in reducing congestion, improving traffic operations, improving overall safety, and in analyzing incidents like the one we show on the right-hand side. Next one. These are the objectives of phase 1. Develop a protocol that I mentioned. I have to complement the 14 CFR Part 107. We have to design and conduct an experiment, and already that experiment, we are working together on that, and that's where Adrian Gonzalez helped us, establishing the standard guidelines for effective and safe use of drones in corridor-wide detection, but we need to establish which are the control variables that are more critical. And we need to establish the or pertinency associated with weather, because we know weather is also a critical variable, not only daytime, but if it's raining. And we have mentioned the type of pavement can do a difference if it's a rigid pavement versus flexible pavement. Next one. This is summarizing. I just already mentioned they're concentrating on developing the vehicle detection algorithm, and we were concentrated on the protocol for high-speed freeway facilities. Already, Josue mentioned we were that day when they did the thank you for the invitation, and this is what he was showing. How you address a particular incident. This was a single vehicle incident that impacted the guardrail, and at that point, even the airbags open, and how you do all the logistics when that happened, and the TNC provide information that the key players are there to be sure that we avoid also a secondary crash. And that was done 2 or 3 weeks ago. Next one. This was inside the TMC that all of us are going to be here tomorrow. Porter, everyone from South Florida, pay close attention. Please close attention right now. Okay, this is the TMC. Take a guess. This is the executive director that you just met. Okay? He was there paying attention. He was paying close attention. In my opinion, he was scared to death that we don't have an incident, and Colucci is here and all of us, but we didn't have an incident. Thank you very much. Trust us, okay? Then what happened? We have the connectivity that the TMC, we can have 7 of the cameras that we can have the information of the drone. Therefore, we were connected with the drone, and you're seeing actually what the drone was showing to us, and we can give instructions on how to do at that particular time. Next one. Then this is our research methodology, because the ABC is on our methodology. Thank you to Dr. Adrian Gonzalez, the graduate student, to help put this together. Definitely, there's a lot of information on how we do this in 3 steps. I'm going to show now split in 3 areas, the ABC on our research program. Next one. That was part A. Understanding that the corridor-wide surveying using USA, small UAS, with the leadership review, very similar. I'm not going to, there were similar leadership review, but I'm not going to show that here. But we have areas that you should keep in mind. We have about pertinent transportation topics that are associated with congestion, applications and regulations of using drones, FAA and other ones, and also best practices and the experiment design. And then we have to buy the drones. We didn't have the drones. That was part of our project. Next one. Then we have to do drone training. For with all of us, we were learning, take the exam, and then also purchase the equipment. And then step number 4 was the experimental design. Okay, very similar to what already Dr. Yuyu showed, because it's a drone height, the angle, and other considerations. Therefore, we have to establish what are our control variables, and then we started to establish the performing the experiment, where we have to select also a test site, because we have to learn. Therefore, some of these things that we are showing is the different places that we went to learn how to use the drone, what happens, learn about the filters of the thermal images of the new drones. Next one. Statistical analysis, conclusions and recommendations, and also validation and verification and validation. Okay. Therefore, leadership review, we concentrated on 4 major areas. We concentrated on surface transportation topics. Already we mentioned UAV application with specifications, experiment design, and missile detection. Okay. Next one. These were the drones that we purchased. Okay. We have 2 drones in this project: DJI Mavic 2 Enterprise Advanced and Autel Evo 2 Pro 6K. Next one. What happened? As has been mentioned, you see, we have EDC at the Puerto Rico Local Technical Assistance Program. Since day 1, we have been on the Everyday Counts initiative in 2011. And also I mentioned the Next Generation team. We run a little bit of that on our office. I have been there for the last 10 years. And that we have also other drones. Therefore, we use our students to learn. Brian and Luz went, executive director, they went to lab to PR 116. Therefore, on the microsurfacing project, our students learned a different process. And there are different areas when they were learning. They went to a parking, visit the civil engineering department also to learn in an area where we are located. And also practice in an open field. But what I want to tell you, there was different locations to understand how to use the drones. Next one. This is the protocol. I told you it's in 3 stages. The executive director, before, during, and after, very pertinent. And we also knew that at the time of the purchase have to be a USA manufactured drones. That was part of the critical issue on the purchase of the equipment. And to summarize, I just showed you 7 different areas. Drone selection process to buy USA, understanding the regulations from 14 CFR Part 17, the different best practices, lessons learned from different agencies. We coordinated with Juan Rivera in May. We have with the Federal Highway Administration, innovations in drone applications, and we learned a lot from FAWA, from Utah, from Ohio, Indiana, and so forth. And the important and pertinent aspects of the weather is not the same weather that they have in Canada and northern United States as we have in Puerto Rico. And the pertinent balanced surface transportation operation. As we continue along, next one, I told you this is the executive director before, during, and after. These are some of the items on the protocol. This is the protocol that we're showing you. There are 7 pertinent items. Okay, you need to have the credentials of the pilot and the equipment, the airspace clearance that you mentioned, Class B. We only have to understand Class B, Class C, whatever is pertinent on FAA, weather conditions, emergency contingency, flight plan. We have to plan ahead of time. Not just, oh, we're going to start here. No, you need to understand the area where you're looking. And we start with the different actions. The same thing is a simplified protocol. The next one shows you the during. The durance. What we have to do is there's interference, manual operations, what challenging with content data collection. The issues of the battery. Battery is a big issue. Every time we found if it's very high, it's a problem. Okay, how are we going to charge? We need to have extra batteries. You assume the batteries are going to last what the manufacturer is telling you. It's going to last 45 minutes. No, it lasts 30 minutes, 28 minutes. But one issue is that the batteries, and you have to give them maintenance. Therefore, that's very critical, whatever you do. And the crew members, you cannot put everyone. I mean, 95 degrees without water. You have to have canopy, but you have to be also conspicuous. Next one. On the after, what we have to do. But this is what we did at the first part of this project. Next one. And it's showing the 7 steps of our research framework. We have to recognize the problem. She mentioned the research question usually. Shows all the different experiments. Let me clarify the variables, control variables at different levels. What is the response variable based on those control variables? The type of experimental design. We perform the experiment, the statistical analysis, and conclusions and recommendations. That's our project. This is our framework of our experimental design for a high-speed, freeway high-speed, or high-speed multi-lane corridor. What will be the experiment that we have planned? Okay, I'm going to go slower here. Therefore, we have to understand at what height we're talking about. Is what is the condition, if it's day or night. You can see day or night, the different heights, and also the camera angle. And it's showing that this is the first replicate on the right hand side, and then on the other part you see the other replicate selected randomly. Therefore, this is showing you how will be our experimental design that we're working as we speak. Next one. This is thank you, Paul. We adjusted your figure. You know, we're giving you credit. Therefore, this is the experimental design with the control variables, showing the height above ground. It's showing the angle and understanding the field of view of lens, and all the other pertinent information of the drone. Therefore, we're showing the initial condition, distance from the road, because the drone is at one position, but the drone, there's a requirement you cannot exceed 2,000 feet from your point. But you can have a waiver to have more distance. But also some drones come already fixed with 1,500 feet. And you have to adjust the drone to the default values to extend so you can see more. When we have the incident on Monday, November 29th, I have to ask Brian, as you can extend the field of view so I can see the length of the cube. He adjusted real time so I can see more of the cube in that horizontal curve. Next one. We did the first experiment on a multi-lane. That's a PR2 in Mayagüez. This is a Mayagüez mall. People will be familiarized with the intersection of 343. That is the boundary between Migueros and Mayagüez. And we evaluated the drone height at 100, 200, and 300 feet. And it is showing you the different 100, 200, and 300 feet. Next one. And we're almost done. We also have to evaluate the different filters, as mentioned also by you. These are 4 shields: black hot, iron red, white hot, and fluoride. What we found out, very similar. I mean, there's a lot of noise, and we need to find what is the adequate algorithm to this trade-off, this balance. We call balance of interest in lawyers. There's this trade-off because it's not perfect. You know that you need the thermal, but you know it's going to be bad. It's going to hit you. It's going to be a little bit of, not a big blow, not a low blow. It's going to hit you a little bit. But you know, 50 feet is not good. It has to be higher, okay? And also the angle has to adjust as well. Next one. Then already this is what we're going to do tomorrow. This is PR52, Caguas North. Where is the TNC here? Show me, Josué.
It should be on down here.
Down here, right? Down here. This is here. This is what we did with our drone. That is showing this was when Brian and Lucy were there, that's right? What day was that? Monday, November 29th, right? Okay. You can see that was before. I mean, you arrived at what time? 6 o'clock. At what time did you arrive? At what time you started recording?
Right. Recording
6:30. 6:30. Okay, this was 6:30 in the morning, Monday, November 29th. I'm almost done. Next one. Next one. I'm going to accelerate a little bit. Okay. Okay. We did some work at that day. The executive director was there with us. That's us when we were making the test. I need to show you the information of the incident. That's what is pertinent right now to finish my presentation. Next one. There it is. Next one. There it is, okay? This is Monday, November 29th. All of you that come from south, the north, Ponce, and all that area. That day, if you remember what happened, that incident happened at 6:53 in the morning. We are 52 kilometers, 14.6 at the entrance of the DTL. Okay? Houston, we have a problem. Executive Director of the Highway Transportation Authority, we have a problem in a Monday. We have our 2 drones. That video that we're going to show, that was at the drone altitude of 250 feet. And the drone distance was 100 feet, then 600 feet. And we need to show the length of the queue. Okay, is there a video there? Luz? No? Huh? Oh, was before, that's right. Okay, next. Where is the length of the queue? No, you're going backwards. No, there it is. Okay. The drone altitude was, like I mentioned, between 200 to 250 feet, because he was changing the altitude. We were located and we extended between 1,500 feet, we extended to 2,500 feet. That's about half a mile where we were located. And also we need to have the observer so we can see the drone as well. And the queue, I just want to clarify, we could not, Executive Director, we could not see the queue, the complete queue. Okay, that's one limitation that we need to clarify, Didier Valdez. We saw the queue, we know when it's finished approximately. We had approximately, with the camera, 1.7 kilometers that we can see the queue, okay? But what happened? The queue where it started was in front of us, 600 feet, and we already with the camera, we lost those 600 feet, okay? That way we can start, and we have to see higher. Okay, then to analyze the queue with the people that will be next semester, we need to do a little bit of fine tuning when it happened. And in our case, it was a reverse horizontal cut, okay? And we're saying that approximately we're about 280 vehicles on that on one lane at that point where we could see the queue, okay? Therefore, keep in mind, already 280 vehicles are on the queue. There were probably, we were talking about 6 trucks at that point. Each truck was like 3, based on the assumption that we made, 20 feet space in each vehicle. We were talking that the passenger car equivalent of a truck was close to 4 vehicles, okay? It depends, it was a 75-foot long or it was a 60-foot long. If he has a 53-foot semi-trailer, the combination, the van is 75 feet. That would be 4 PC, passenger car equivalent. Therefore, we need to keep that in mind. What is the height when we have a queuing? Okay, conclusions. We're experiencing and implementing the use of drones for the last 6 years, very impressive. Surface transportation programs in the United States, at one point, 41% of the drones were being used by all state DOTs. Nowadays, all 8 agencies use 100% of the drones, but for different applications, not for traffic incident management. And one of the potential benefits that has been proven right now is between 40 to 7% in DOT surface transportation activities can be reached using drones. And of course, safety. Safety is also very pertinent. And next one. By 2023, we're expecting that in surface transportation programs and with the new bill that has been approved, that this is expected to triple the current market of 2.7 drones commercial drones with significant improvement in accuracy and overall worker safety. Productivity data collection combined with improved safety and efficiency, and combined with the protocol and the different levels of data, would be a part of our contribution for understanding the connection with the improved vehicle detection algorithms. And both of our students are working together in that area, and we are helping also to understand the calibration that needs to be done. And as I mentioned, not only counting, has to be classification. Therefore, to finish, USA application for freeway and vehicle incident detection in freeways can be enhanced with any spatial coordinates, taking advantage of contour, dense GIS features, 3D models, video images, as these emerging technologies will help us together. And I'm done already, and we're constantly calibrating our protocol. Next one. I want to acknowledge, to finish the presentation, Dr. Lee, that is on the other line, he's our PA, he's our chief, our CEO, Sean Lee. Thank you, Sean. Thank you for allowing you people to come here and you stay working at home. We are so sorry you're not here. A big call from Puerto Rico. Of course, we get funds from the University Transportation Centers. And I want to acknowledge you and your entire team. You have been an excellent experience that I have had, and I really will miss you next semester. But we will continue technology transfer. So your team, and of course, Dr. Figueroa, he's also the director of the Civil Infrastructure Research Center. He's going to be celebrating 30 years since it was established, and that's why we run this NICR 4-3 project. I believe that is over, Imali. Thank you very much. Muchas gracias a todos. Espero que hayan entendido. Después se las puedo dar en español a la gente de Puerto Rico. Muchas gracias, doctora Cruzado, por el tiempo adicional. Que pasen un bonito día. Feliz Navidad y próspero año nuevo.
Okay, those are our last presentations. So I understand that we have, at the moment, we only have one question. And this question is going to be for Dr. Juju, which is, what UAS are you using? That's like 3 questions in one, by the way. What were the periods of analysis, and how did you address the battery limitations?
Oh, the battery.
First one, what are the UAS, the drones that you're using?
Hotel Evo. Hotel Evo 2 is the same.
It's the same that Dr. Clucci showed. Dr. Clucci has the 2 drones. One is the red one, the orange one.
Yes.
The one that we used, actually orange one, but we have 2, the same brand, but with the different sensors. So we have one with only 1 sensor, another one with dual sensors. Yeah. What were the periods of analysis? When you say periods, the morning, the afternoon, you select one period of analysis, like from 4 to 6 to 6 hours. Yeah, so we actually collect the data both for more kind of free flow traffic condition and congested traffic condition. So for the congested traffic condition, we actually collect the data during like the afternoon peak when the congestion could be built up. So I think in our data set, eventually we want to make the data set public accessible, because this is the NICR, this is USDOT, UTC sponsored, with the federal money. So we're going to make it public accessible, and you will see that we have data showing when it was collected, where it's collected, and the details of the data. Yeah, so for anybody who's interested, you can feel free to contact me. The last question was about any battery limitations. If you have any issues, how did you address those issues with the battery? Oh, the battery, we actually, for each of the drone, we got 2 batteries, right? So 3 batteries. So usually when we go out to do the data collection, we fully charge all the 3. And each of them can fly about 30 minutes-ish. And what we have done now, because this is kind of research process, we keep on collecting like a 2 minutes-ish video at the different with the different parameters. So we collect 1 and get the drone down, we adjust something, we collect again, etc., etc. And we change the battery if it's
the first ones die or second one, third one. So, but I think in the future, we could all imagine in the future, we could send out a bunch of drones. So we are looking into also multiple drones, how we can apply the multiple drones for the monitoring and data collection, and also the incident detection, automated incident detection algorithm. So in the future, it could be a bunch of drones in the air, and the battery could be an issue. But I think in the future the battery technology will be improved, and
And there's also hybrid.
Yeah, and also I want to mention there's a hybrid which you can use a diesel. So it's like a hybrid vehicle. You use the diesel, but that we actually at the beginning we thought about that, but that kind of drone is very expensive. It's about, I think it's about $30,000. So we cannot afford with the funding for this project. So, but for stakeholders, if you have more funds, you can consider using hybrid. And those one actually can fly up to 3 hours.
Oh, wow.
Yeah. So, 3 hours basically cover the peak hours, which is most critical for the incident detection and management. Yeah. And we have that information actually at the beginning. I didn't mention that as Dr. Crucci gave more details about that. We have gone through similar process as Dr. Crucci mentioned. We also look into different kinds of drones, how that could be used. The fly range, time, etc., etc. So we have that information. And then, if anybody's interested to save your time, we can share the information with you. Yeah.
Okay, thank you so much, because we're thinking about actually, I'm sure Brian and Luz did it. I mean, go one drone while the other one is waiting, and when you're expecting the drone the battery to die, then that's when you overlap it with the second drone. That way you can try to have like almost a continuous video. Do we have any more questions? It doesn't look like we have anybody from the audience here at the CAPF. We have now, Dr. Adrian Gonzalez came here, and now I'm so tempted to ask him questions, but it's 11:53, so I'm not going to do it. Don't worry. Oops, we have one question. No? There's one announcement.
La última palabra clave de la mañana de hoy es manejo de incidentes. La última palabra o frase de la mañana de hoy es manejo de incidentes. Gracias.
I think that is a great idea. You said that you have to make an announcement?
Yes, we already received other comments from our participants. We have Engineer Francisco Klein here mentioned. He's our recipient from the Decade of Action for Road Safety. He mentioned the pertinence of safety on vest. Remember, we're wearing vest and we're doing our work. If you're working during the night or early in the morning, remember to use class 3 vest in the process. Thank you.
So I think with this, it concludes this summit. I appreciate everybody's input, the presenters. Thank you so much for your presentations, la redundancia. But I mean, this was a great experience, and I hope you all enjoyed it. Okay, so have a great lunch and a great day, and that's it. It's a wrap up.